Hi, my name is Nguyen, and today I would like to present our research paper with the title Big Data Analyses Show New Ways for the Prediction of Energy Consumption for Sustainability Assessment. Here the focus lies on a reduction to a few relevant input data for a still accurate energy prediction of existing residential buildings. According to the Energy Performance Building Directive, all member states of the European Union are obligated to pursue energy efficiency guidelines in buildings. And this had to be done by implementing national regulations in order to promote the energy and resource efficiency of their buildings. There are many different quantification methods like calculation-based, measurement-based or hybrid methods. But in most EU countries, a steady state, so a calculation-based method, is used for energy performance certificates. However, it's not specified which method exactly must be used here. So for example, in Germany, you can choose between steady state and bill-based methods. Here on the left-hand side, you can see an energy performance certificate based on the steady state method for a typical one-family house in Germany. And on the right-hand side, there is for the same building a bill-based energy certificate. As you can see, there is a huge difference between the calculated energy demand and the measured energy consumption. For the most of the house owners, this is very confusing, because with the steady state method, it seems like the house owner has to pay a lot for heating, much more than in reality, but with the bill-based method, this old building from 1983 looks like a newly built house with good insulation standards. The difference between the two methods can be explained as follows. The steady state method uses roughly estimated data from the building and standardized boundary conditions, but does not consider any specific heating or ventilation behavior by the user. On the other hand, the bill-based certificate only considers energy consumption bills of the last 3 years, but without considering any data and information about the actual building itself. So there's no indication about the insulation standard of the building, and it's not possible to recommend any refurbishment measures. Also, here the user has a great influence on the outcome, whether he uses a lot of heating during the winter time or opens the windows a lot. This discrepancy between calculated and measured energy consumption also appears in many studies like this one. A field study with 1 and 2 family houses in Germany, where the difference between calculated energy demand and measured energy consumption can range from 50 up to 300%. Therefore, the main goal of this research project was to develop a new approach with big data and artificial neural network to predict the energy consumption of existing residential buildings. Our model should only require a few easy-to-determine input parameters for the prediction, but still possess a high degree of accuracy. Also, a special feature of this project was the integration of the ANN model into a calculation web tool, which should be easy to use and accessible for non-professional users. The data which I entered into the web tool were then used to further train the algorithm and increase the accuracy of the prediction model. So at first we had to collect data that includes useful information for our project. At the same time, we had to decide which information or input parameters were essential for the energy prediction and also easy to determine for the user. Then we had to clean and prepare the data. After that, we trained the ANN. This was done with 12,500 data tuples and validated the algorithm with a dataset of 1,500 data tuples. In addition, a web tool or a demonstrator for a web tool was developed where house owners can enter a few parameters of their building and get a prediction of the energy consumption calculated by the ANN. But during the project, the web tool was primarily used to collect more data to further train the algorithm in order to increase the accuracy of the prediction. Now, I would like to explain how and what input data are collected from the user in order to train the ANN model. Marked in green are the mandatory input data that must be entered or answered by the user. Without those data, the ANN is not able to predict any energy consumption. But as you can see, there are not a lot of questions here. In gray are optional questions or input data. The more questions the user is able to answer, also about refurbishments or the energetic condition of specific buildings components, the more accurate the result will be. Input data, which is entered directly by the user and goes directly into the ANN model, are called first-hand data. Input data that are generated or estimated by the computer because data are missing or based on information from the user are called second-hand data. These are, for example, generated as so-called building component condition factors for windows, external walls, roof, and basement. Now, this diagram here on the right hand side compares the predicted energy consumption using ANN with the real measured energy consumption. In gray dots are the results for the training dataset, and in black dots are the test datasets. In order to evaluate the accuracy of our prediction model, we use two kinds of error measures. The mean absolute error, where we get a value of 41 kWh per square meter and year, and the weighted mean absolute percentage error with a value of 22%. If you remember the diagram at the beginning with an error range of 50 up to 300%, this result here is pretty good. So, in conclusion, in this research project we were able to develop an ANN model which outperforms conventional methods. However, there are still some limitations. At this moment, the ANN only works for 1 and 2 family houses built before 2001 and located in Germany. The accuracy of the current prediction, which you saw in a previous slide, only applies for a limited energy consumption range, that is the blue area in the diagram here, and also only for a limited net running area. So for future work, it would be interesting to include or collect more data from buildings outside of the range of the just mentioned limitations. It would be also interesting to include user-specific data like user and tenants or size of the household as input data for the ANN. And finally, in the future, with more available data, the ANN should be able to issue recommendations on refurbishment and the estimated cost. Thank you very much for your attention. If you have any questions, feel free to contact me via email, in case my future me is not here right now.